So, question 4 involves harmonic motion, and the problem reads, a guitar string with a length of 66 centimeters is fixed at both ends. A asks us, sketch the fundamental mode, i.e. the first harmonic, the second harmonic, and the third harmonic of vibration on the string. So, using my knowledge of what they look like, I have simply sketched the first harmonic mode, the second harmonic mode, and the third harmonic mode for us right here. So that's part A. Part B asks us to calculate the wavelength of each of these three modes. So, using my knowledge that for the first harmonic mode, wavelength, or lambda, equals 2L, or 2 times the length. For the second harmonic, wavelength equals L, and for the third harmonic, wavelength equals 2/3 L. I can calculate 132 centimeters as the wavelength for the first harmonic mode, 66 centimeters as the wavelength for the second harmonic mode, and finally 44 centimeters for the wavelength of the third harmonic mode. So part C asks us, if the fundamental mode creates a frequency of 440 hertz, what are the frequencies of the second and third harmonics? So, using these from the chart on harmonic motion in a string with fixed ends, I know that for the frequency of the first harmonic mode is going to equal V over 2L. The frequency of the second harmonic mode is going to equal V over L. And the frequency of the third harmonic mode is going to equal 3V over 2L. So if I'm given that V over 2L, or the frequency of the first harmonic mode, is 440 hertz, I can find the frequency of of the other two by, for the second harmonic mode, multiplying this frequency by 2 and getting 880 hertz. And for the third harmonic mode, multiplying this frequency of the first harmonic mode by 3, which will give me 1,320 hertz for the frequency of the third harmonic mode. So D asks, if the fundamental mode creates a frequency of 440 hertz, calculate the speed at which waves propagate along the string. So, if the fundamental mode has a frequency of 440 hertz, and I know that I can use my V over 2L equals 440 hertz from right here, I can actually use this equation to solve for V, since I know what L is, 66 centimeters. So I'm going to solve this as far as possible with variables. So I'm going to end up here with V equals 440 hertz times 2L. And if you haven't already noticed, this is the equation V equals frequency times wavelength. And then if I plug in my 0.66 meters, or 66 centimeters for the length, I'll get 440 hertz times 1.32 meters equals 581 meters per second, and that is the speed at which waves propagate along the string. So one key element to solving this problem well is knowing V's for harmonic motion in a string with two fixed ends, and if the problem were to be in a pipe with fixed ends or a pipe with one fixed end, it would be important to know those as well, and they make the problem not only a lot easier but possible. So that is something that a student would need to solve this problem, and it's a key step, and so that's how you do it. Thanks.